In this video, we will be talking about how to graph by completing the square. Given a quadratic equation, y is equal to ax squared plus bx plus c, we want to rewrite this in the form of the vertex form. Y is equal to a times x minus h squared plus k, where we talked about this in the previous video already, that vertex represents h and k. Remember, the k stands the same, h, you negate that answer. So if it is negative h, vertex is at positive h. In this example, rewrite y is equal to x squared minus 4x plus 1 into a vertex form. In order to do that, we need to first rewrite y is equal to x squared minus 4x and a little space and plus 1. We're going to complete the square. Remember, we usually take the term b, divide it by 2, then square it. Negative 4 divided by 2, and then square that number. We get 4 as an answer. So we're going to add 4. Since we're adding 4 onto this equation, we're going to subtract the 4. So in that way, we're not changing the whole equation. Now we're going to complete the square. The first 3 terms, they factor out as x minus 2 squared. Simplify these two numbers, we have negative 3. So y is equal to x minus 2 squared minus 3 is a vertex form of this equation. Where is the vertex? Vertex is at, negate this answer, so positive 2 and negative 3. You may FOIL this back to see if you get the original equation to check your answer. For example, to check, we're going to FOIL this equation, y is equal to x squared minus 4x plus 4 minus 3, which is equal to x squared minus 4x plus 1. See, we have a question that we started with, so that's one way you can check the answer. I suggest that you pause this video and try the problem on your own. First, we are going to rewrite this as a y is equal to x squared plus 4x, little space, plus 3. We're going to complete the square by taking the second term, positive 4, divided by 2, then square it, which is positive 4. In order to keep the equation same, we need to subtract the same amount. So we're really adding by 0 here. First 3 terms, they factor out as x plus 2 squared. Simplify the last 2, we have negative 1. So vertex is at negative 2. Remember to negate that answer, and negative 1. To obtain the graph of y is equal to x squared plus 4x plus 3 from a graph of y is equal to x squared, how do they translate? Well, we are given here y is equal to x squared, which has the vertex at 0 and 0. Now that vertex has been shifted to negative 2 and negative 1. So there has been a 2 units to the left and 1 unit to the downshift. This is not only true for the vertex, but the remaining of the points on the graph. Every single point on y is equal to x squared gets translated 2 units to the left and 1 unit down. So this point on y is equal to x squared will get translated onto 2 units to the left, 1 down, so it'll result over here onto the y is equal to x squared plus 4x plus 3. What if your leading coefficient is not equal to 1, but instead 3? In this case, we're going to factor out the 3 on the whole equation, making it 3 times x squared minus 4 over 3x, a little space, plus 1 over 3. We're going to complete the square by taking the term b, divided by 2, then squared. Negative 4 over 3 divided by 2, that's the same thing as a multiply by half, then square that number. So we have negative 4 over 6 squared, which is the same thing as a negative 2 over 3 squared. Again, this is then 4 over 9. So we're going to add 4 over 9, then subtract 4 over 9. Then we're going to factor out as an x minus 2 over 3 squared. Simplify the last two. We have the common denominator of 9. So the first fraction is a 3 over 9 minus 4 over 9 makes it negative 1 over 9. The common mistake that students make is that this number 3 is still factored out. So keep it outside of the whole parentheses. Then we're going to distribute on here and onto fraction negative 1/9. So finally we have 3 times x minus 2 over 3 squared minus 1 over 3. Vertex is at 2 over 3, negate that answer, and negative 1 over 3.